You know, in the history of computer memory, there was this huge battle, a showdown really, between permanent and erasable data. Today, we're going to unpack that very story, the clash between PROM and EPROM.
Seriously, just imagine that for a second. You get one shot to write down your thoughts, your code, whatever. No erasing, no crossing things out. One tiny mistake, and you have to toss the whole notebook. Sounds kind of stressful, right? Well, that is exactly the problem early computer engineers were facing.
To really get why this was such a huge deal, we have to rewind a bit and start at the very beginning with the original concept of read-only memory.
Think of ROM as a mass-produced, already published book. The story gets printed at the factory, and once it's done, it's done. You can read it a million times, but you can't go in and change a single word. It was designed for permanent storage of those absolutely essential instructions a computer needs from the get-go.
Now, that's great for big companies, but what if you wanted to write your own book, your own program? Well, that's where our first hero of the day enters the story, the programmable read-only memory, or PROM for short.
PROM was a total game changer. It was like getting a blank notebook. For the first time ever, developers could buy a blank chip and burn their own custom firmware onto it for things like early video game consoles or microcontrollers. This wasn't just a small step forward, it really opened up the world of hardware design to a lot more people.
But, and you knew there was a but coming, here's the catch. This brings us right back to our permanent ink analogy. PROM got the nickname WORM, which stands for write once, read many. You got one and only one chance to get it right. And this whole write once design, as you can probably guess, created a very high stakes problem. There was absolutely no room for error. I mean, what if you found just a tiny bug in your code right after you'd programmed the chip? Or what if a single bit got flipped wrong during the writing process? What then?
Yep, that's it. It's a dud. A digital paperweight. Any error, no matter how small, meant the entire chip was totally worthless. You had to throw it out and start over with a brand new one. Just imagine the drag this put on innovation. Prototyping was slow, it was costly, and it was incredibly nerve-wracking. The world desperately needed an undo button.
And that brings us to the next brilliant innovation in our story, the erasable programmable read-only memory, or EPROM. All of a sudden, that permanent ink wasn't so permanent anymore. EPROM introduced a way to wipe the slate clean and start over. And not by scratching things out, but by using a very specific tool, powerful UV light. This was revolutionary for developers because it completely changed the economics and the speed of product development.
What's so fascinating here is how physical the solution was. EPROM chips had this really distinctive little quartz window right on top. And that wasn't just for looks. That window was a portal that let UV light shine directly onto the silicon inside, which would reset it to a blank state so you could reprogram it. Erasing the chip was a very hands-on process. You'd take it, put it under a strong UV lamp for a few minutes, and poof, the data was gone. The chip was ready for a totally fresh start. It's just this brilliant example of a clever physical design solving a critical digital problem.
So now we have the one-shot PROM and the erasable EPROM. Let's see how they really stack up when we put them side by side. You know, when you boil it all down, the whole story is about the power of a second chance. It's about the ability to fix a mistake, to iterate, and to improve. And that right there is the fundamental divide between these two technologies.
Looking at the comparison, you can see the trade-offs really clearly. PROM was cheaper and simpler, sealed up in plastic. But EPROM, while yeah, it was more expensive because of its MOSFET construction and that special quartz window, it offered something priceless: error reversibility. If you made a mistake with PROM, it was game over. With EPROM, a bug was just a temporary setback, not a financial disaster.
And that really is the heart of it. That one simple fact, erasable versus non-erasable, changed everything about how software was developed for hardware. This ability to iterate just unlocked a way faster pace of innovation across the entire electronics industry.
But let's be honest, having to pull a chip out of a device and stick it under a special lamp isn't exactly user-friendly. It was a fantastic step forward for sure, but the story of erasable memory was far from over. Which leads us to our final question. What happens when you need an undo button that doesn't involve a UV light? What came next?